Hi everyone, welcome to the SQL Server Query Tuning Best Practices series. We're in part 6 of 6. So that means today is the final episode. How do you feel about it being the last of the series, Aaron?
I'm kind of torn. I'm a little sad that it's over, but I've had a lot of fun, and it is some work, so it's good to have it out of the way as well.
Yeah, exactly. It's been fun. Talked about a lot of different things over the past few weeks. But, like you said, like Aaron said, there's a lot of work to be done to prepare all this. So hopefully it's been useful and beneficial to you. My name is Kevin Kline. I'm the Director of Engineering Services here at SQL Century. And you can follow me on Twitter at KE And with me today is my good friend, Aaron Bertrand. Hi, Aaron.
Good morning, sir. How are you?
Oh, I'm doing well, doing well. After having spent all this time, 6 weeks on this, do you feel like there's still a lot of things to talk about?
Yes, a lot of the things that people do in SQL Server deserve some treatment in one way or another, and I've been doing this for a long time, and I see a lot of these problems happen, and I think we've touched barely the tip of the iceberg here in terms of helping people tune their queries better.
Yeah, that's kind of my sense of it too, that we've hit the tip of the iceberg, some of the big and obvious problems, but there's a lot of ground to be covered out there. So maybe if we get enough customer demand, we might come back around and do another 20 some odd patterns and anti-patterns as well in the future.
Yeah, sounds great.
If you are looking for additional information on SQL performance tuning, I encourage everyone to make sure you sign up for our new ebook. Now, this ebook is available today, right now, on the Amazon Kindle web store. It's $10 on the web store, but if you drop an email to us, you can send it directly to me if you like at kekline@sqlcentury.net. We'll get you on the list so that you can get a free copy of our nearly 300-page High Performance Techniques for Microsoft SQL Server ebook. Also, on August 1st of 2013, we'll be kicking off SQL Century TV. And this will have all of our videos for all 6 in this series, as well as many more. You'll also be able to get the slides and all of the demo code that we show you during these sessions. So if you saw a query that you thought was really neat and you're kind of dreading going back and freezing the screen and then typing in all the stuff that we have in the queries, never fear. We have all of those queries available for you, and you'll be able to just download them at the click of a button and put them into your code library. Now, just a quick note too, you can see SQLperformance.com, and that's at the bottom of that image of the book. Take a look at that website. That's where lots of great blog posts and articles and so forth come from that compose that ebook. So there's lots of great free advice there all the time. Now, this is also your last chance to win one of our big giveaways for the big PASS Summit that's coming to Charlotte in October of this year. So PASS is the Professional Association for SQL Server. It's the biggest professional association of any Microsoft technology, actually. And so the annual conference is now about between 5,000 and 6,000 people. And at the end of that week, on October 18th, 3 of our winners who win the drive along package, the ride along package that is, and the rookie experience packages will get to take one of these NASCAR race cars out for a spin at the Charlotte Motor Speedway. So it's going to be a lot of fun. So all of the sessions between the start of the series, way back in June, all the way through the end of July 31st, that gets your name into the various drawings that we're going to have on July 31st. So I hope to see you there. All right, so with those kind of early preparations out of the way, let's talk about what we're going to cover today. We're going to talk about 4 different topics. Aaron's going to be covering 2 of those, and I will take 2 of them as well. So Aaron is going to be talking about efficient ad hoc sets, as well as some best practices for comma-delimited parameters involving table-valued functions and things like that. I'm going to be talking a little bit about implicit conversions in our SQL code, as well as some best practices around the kind of temporary structures that we use inside of our SQL code. So we're each going to be taking 2 topics today, and a lot of good information because these are things that we do see all of the time in impinging or impairing SQL Server performance. Now, just to kind of give you a little bit of scope, we have, as we mentioned, been doing this for the past 2 months. And so we've covered actually more than 23. That's the number that we have here, but we've made quite a few bonus call-outs in our different sessions over the past couple months. So if some of these look interesting to you, like what's a kitchen sink stored procedure, or what's the transitive property of indexes, do be sure to go back and take a look at our other sessions on SQL Century TV, because there's a lot of good information for you to find there. All right, so Aaron, let's talk about those ad hoc data sets.
Sure. So I see a lot of people using recursive CTEs to generate a set of numbers or a set of dates on the fly so that they don't have to create a table. The other day I talked about how merge is this shiny new candy that people are flocking to in droves, even though it has significant issues. I feel kind of the same way about recursive CTEs that are used to derive a contiguous set. And the bigger the set, the bigger the problem. So tables are cheap, folks. As long as they're referenced enough, they're always in memory and don't require tempdb support. But I will get a little more into what I mean by that by showing an example. So I'm going to take the screen. All right, so first I have a simple demonstration here of populating a numbers table and a calendar table. The numbers table has 32,000 rows, and that allowed me to use a small int, which is half the size of a normal int, and supports a lot of the things that I would typically do with a numbers table. You might need more than that, that's okay. You can just change it to an int and change the way that this query is structured, but that's the basic idea of how to create and populate a numbers table. And now we have a calendar table right below that uses a date, which is 3 bytes, uses that as a primary key, and we can use the numbers table to populate that. Now this populates the calendar table with 32,000 plus rows, which covers about 89 years. If you need more, it doesn't take much to add, and in fact, in this case, you don't even have to change the data type. You just have to pull from a larger set than the numbers table that I've created here. I'm also going to demonstrate how small these are. First, I'll just show you what the calendar table has in terms of range. So it goes from 2000, the first day in 2000, to somewhere in mid-September of 2089. And that's just, I could have tailored that a little better to end at the end of a year or what have you, but I figured that for this demo, 2089, September 16th would be sufficient. Now, if we take a look at the space, Kevin, do you have a guess at how much space these tables take up?
I have no clue. I would think it's going to be pretty big.
Mm-hmm. So the numbers table takes up 400K, and the calendar table takes up 500K. So to have 32,000 numbers and 32,000 dates, we're talking about a meg. So if you don't have, one of the biggest objections I have to using a numbers table and a calendar table, and I've been talking about doing this since the SQL Server 2000 days, and constantly I hear, oh, but a table takes up disk space. And when you read the data into memory, it takes up memory. If you don't have a meg of memory to support this, or a meg of disk space to support this, then there's a bigger problem, and maybe you're in the wrong webinar today. Now, so what would I use this for? What would I use a calendar table for? One of the things is, let's say you want to run a sales report that shows all 31 days of a specific month, let's say March, even if some days in March had no sales. So what I see people do first, and this is where a lot of questions on Stack Overflow and Stack Exchange come up, is people will select convert date, order date, and account, and then group by convert date, order date from the sales table, right? So that'll return 31 rows if there are sales on every single day. But if there are sales missing on any given day, that row will be missing from the result. So that can make for some funny looking reports if you're building graphs or you're expecting 31 rows in the output and you don't get them. So you wouldn't, if you need to actually represent all of those days, you might first try a recursive CTE. So let's take a look at this. We've got we've got 2 dates that we've created. So March 1st to March 31st. And then inside of the CTE, we've got an anchor row, which is just selecting the constant. And then we're unioning that with basically looking back at the CTE and saying, add a date to whatever comes out of the CTE, right? And then we do that until we hit our end date. So then on the outer, we select the start of the range and then the end of the range. So basically the next day. This is so that when we're using these base dates as queries against underlying tables, it doesn't matter what the underlying data type is. We can use the start parameter, which I just called S, just to keep the code clean and not necessarily readable, but just obfuscated and tiny. So we use the start date as an open-ended interval, right? So greater than or equal to the start and less than the end. So basically for every range, and you could do this using weeks or months or what have you, you always say greater than or equal to the start of the range and less than the end of the range. And that gives you a nice little output of interval windows that come out of this function. And then the last row, we have an option max recursion here. We do that to support enough rows to cover a leap year. And this is assuming that your reports only ever need to last a year at the most. So you may need to change that value. So by default, what happens with a recursive CTE is if you have more than 100 levels, you get an error. So your implementation may require a different number, or maybe no option at all. You may not even need to add this line if you only need to support weekly or month-to-month reports. So that's the way the recursive CTE works. Now let's take a look at a couple of other approaches. One is to use a system table, like sys.all-columns. One that's probably more common, just because it's been around longer, is master.s.dbo.spt_values. I'm sure you've used that in the past, Kevin.
Yeah, I have certainly used that, and I've seen that in other blog posts and articles too.
Right. So we can use some kind of system table of something that we know is going to exist on all of our systems to generate a set of row numbers. And then we can use those numbers to derive dates. And basically working like the recursive CTE, but actually drawing from an actual set of rows. And then the third sample here just uses our numbers table. So we add a day to the start date. Well, we first start with 0. So the numbers table contains numbers from 1 to 32,767. So we add every number that we get up until the date diff of those days. So we're basically saying, give me the numbers from the numbers table that are between 0, between 1, and the difference in days between the start and the end of my range. So whether that's 30 days or 365 days or 3,000 days, it doesn't really matter. What this is going to do is going to assign a date to every one of those rows that comes back and then spit them out. And then the last example is just selecting from our calendar. So we just have, we get the dates from our calendar, and then we do the same thing where we apply, we add a day to the back end of the interval.
Even the code there looks a lot more simple.
Looks a lot cleaner, yes, definitely. Mm-hmm. So these all use CTEs, but there's an important distinction. I use CTEs here just to make the statements as congruent as possible, and so that you can compare the complexity of the code, which you just commented on, Kevin, and the approach. And everything else, I tried to keep everything as similar as possible. So the main difference is these 3 CTEs you see on the screen now are not recursive. So that's a big difference that we're going to go into in a second. So if we run these, we can run these really quickly. Scroll up and highlight. Right, so if we run these, we see that every set returns 31 rows. And if we scroll down to the end of the set, we see that our open-ended interval goes from March 1st to April 1st, basically. So for each day, we'll be able to collect data for each day in the set. And all these 4 sets are the same. It ran pretty quickly. It ran in under a second. So there's not really any huge performance things lurking here that I'm very nervous about. But let's take a look at the plans anyway. Okay, so we've got March 1st to March 31st. This is exactly the same code that you just saw on in Management Studio, and I'm going to get the plans. So that's, again, pretty quick. Not really any performance concerns here to worry about. We've got very small durations. We've got a high number of reads here, though, on the recursive CTE, and which is funny because it has the highest duration and the highest number of reads. But if you look at the estimated cost, isn't that a little strange? Mm-hmm. So the estimated cost for the recursive CTE, there's something SQL Server isn't factoring in there when it's deriving that estimated cost. So this is one of those cases where if you're solely looking at estimated cost, if you're generating these plans in Management Studio, and especially an estimated execution plan, and you look at these four options, if you just look at the estimated cost relative to the batch, which one are you going to pick, Kevin?
Oh gosh, well, if I'm just looking at the estimated, I could definitely choose that recursive.
Right. So, and I think this is part of the draw, part of the reason that a lot of people pick the recursive CTEs, because it looks the best. But as we'll see in a moment, this plan is really complex. And then if we go to the one that uses the system table, it's a little less complex. If we go to the numbers table, it becomes even less complex. Right. And the calendar table is absolutely the simplest. So this just uses a clustered index seat and returns those rows. Doesn't have to do any conversions. Has the same number of reads as the numbers table, but a lot less CPU. So if you look at the CPU count, so in order to change, to convert the numbers basically to dates using date add, we have to use some CPU. So even though the reads are the same, the cost is a little bit higher. Now at this data size, this duration, no problem, right? So any of these, it's really not going to matter. It's going to be immaterial. What happens if we look for a larger date range, though?
Okay.
So let's look at a year. So let's go from April 1st of 2012 to March 31st of this year. Take a look at what that gives us. All right, so now we're seeing durations deviate a little bit. Still not much, not enough to worry about if you're looking at a year. Not that big of a deal, right? So depending on what you're then feeding this data into, shouldn't really be a problem. But look at the reads. Skyrocket. 3,200 reads for that. Now, let's take a look at 10 years and see what happens. So let's go to 2002. And then we'll have to change this. I'm just going to put this to 4,000 because obviously outside of a year, we're going to exceed that max recursion that I had there in the first place. So we run this. Should take a little bit longer. Look at the results. Something. Oh, I went over 4,000. Oh,
yeah, you did more than 4,000.
Yeah, so this should have been 2003. Yeah, let's try that. Sorry about that. Oh, there we go. All right, so now we're seeing real deviations in duration. So if you're looking at longer date ranges, you can see where the recursive CTE has a huge penalty. And you can see that just in the number of reads that it's doing. So pretty expensive stuff. Can kind of hurt you in the end if you're using a recursive CTE. And again, these are very simple data types. If you're doing this for multiple values, your CTE is larger and has more stuff coming out of it, you can expect these costs to be even more substantial and more deviated.
You know, this brings to mind, too, many scenarios I've seen in which either myself or someone unwittingly built a big set of queries and things like that on top of what they thought was a table, but was actually a view, which was built on views, which, in a sense, certain levels of recursion across multiple views. And, a CTE, many people tend to think of CTEs as another sort of temporary structure, like a temp table or like a temporary variable. But in fact, it's really just a more semantically elegant way of constructing a view.
Right, and actually I see a lot of people call it an inline view, where it acts like a view. So the thing that really gets people sometimes is if they reference this recursive CTE multiple times in their query, they don't realize that it actually gets evaluated and executed multiple times. The assumption and the way the syntax works, the intuitive way to read that query is, I've got this CTE that I define once, it should only evaluate once. But that's not the case. It actually will be evaluated for every reference you have. So if I see some people write cascading CTEs, and I've done that myself too, but you have to be careful that you're not referencing, the anchor CTE multiple times in each of those things. You've got to, if you're going to cascade, you have to really cascade and not continue to reference the original CTE, or don't be surprised that when it gets executed multiple times.
Mm-hmm. Mm-hmm. Yeah, good insight there.
So if we can go back to the slide deck just for a second. So the next thing that I wanted to talk about is splitting strings
Oh,
and using.
let me interrupt you there for a moment.
Sure.
Um, I think one of the other lessons, you didn't bang this drum very hard, but one of the other main lessons to remind everyone about is the efficiency and usefulness of those numbers tables and the calendar tables. I know a lot of really skilled DBAs who make this part of their regular toolkit. And so it's the sort of thing that I definitely encourage everyone to just put in there, because you're going to find lots of sample code out there that you can reuse, but you will need to have a numbers table already.
Right. Yeah, and I have been beating that drum for a long time. Like I said, in the 2000 days, on ASPFAQ.com, I have 2 articles where I talk about. I think the title is "Why Would I Use an Auxiliary Numbers Table?" and "Why Would I Use an Auxiliary Calendar Table?" So I, it's funny that you use the phrase beating the drum, because I have been beating that drum for years, and I guess it's just it's not something I feel natural saying over and over and over and over again in a short period of time, just because it's been such a common theme for years for me. So.
Well, indeed, and many other of the experts out there. I know Itzik Ben-Gan has talked about it a lot. The late Ken Henderson talked about it a lot. So it's the sort of thing that many of the top talent in the field, Aaron Bertrand also included, have been evangelizing this idea. So folks, please take it under consideration. It is a great idea. Now the next slide on our slide deck actually is about implicit conversions. Do you mind if I go ahead and jump into that?
No, please go ahead.
All right. Well, one of the things that we find is that SQL Server has a lot of very specific details, very specific ways that it works according to the data types that we are telling it to address. So if we've written a SQL, select statement or an insert or something like that, there are going to be certain ways that it wants to handle those data types. And if we tell it to kind of have some interplay between 2 varying data types without telling it that it needs to convert, then SQL Server will have to do a lot of extra work, possibly additional table scans or index scans, in order to get that work completed. So it's kind of like, telling, in my case, I might tell one of my teenage kids to go and get something out of the kitchen and bring it in. And if they don't know where that is, that implies they're going to have to open every cabinet and look in there to figure out where it might be. There's just a whole lot of work that can happen when you make a bad assumption. Now, another thing that is interesting about implicit conversions is a lot of times people understand maybe that they might be occurring in the where clause, where we say something like where an integer number an integer equals, and then we have in the where clause, we have it delineated by the 2 apostrophes so that it thinks it's a string. And so SQL Server is going to automatically have to do an implicit conversion between that integer and the string. But a lot of people don't realize this can happen in lots of different places inside of your SQL and Transact SQL code. It could be in a from clause. Perhaps you have a join statement that is joining 2 identically named columns. They're both employee ID, except one is, one data type and the other one is a different data type. It could be in insert statements, especially if we have an insert with a select, where it's passing in values from another table. If we're passing parameters to a procedure or a function. There's all kinds of other kinds of implicit conversion operations that can even cause errors, or at least issues with the execution plans that don't even naturally kind of show up in the plan, the execution plan that you might, when you're looking at it. Things like going between Unicode and non-Unicode, or passing decimal values back and forth that have different precisions. This can be a really big issue. So a very interesting sort of problems. I'm also going to flip over just quickly to show you this very nice data type conversion chart. And this is one provided by Microsoft. It's one that you can download for free, and they have a color and a black and white version. And just to show you what this looks like, is this coming through okay, Aaron? Can you see that?
Yes.
Yeah, so it's a nice PDF. It's a single page PDF file, and it shows you, for example, you can see here that the date time data type cannot be converted into a binary, var binary data type. If you see gray, then you know that will perform an implicit conversion if you attempt to if you don't put a cast or a convert function with, say, a date time and a varchar, or a date time and an invarchar, something like that. And so it's a very useful chart for you to see exactly what is happening with all the different data types. And in some cases, you can see that there are even some data types that just simply cannot be converted at all. SQL variant and the XML data types are the ones that immediately came to mind for me. But when I was taking a look at it, I had forgotten about the hierarchy ID. So it's kind of interesting to see and be reminded of data types that maybe you don't even use very much. So there's a lot of different kind of fancy handling that you might need to do depending on which particular type data type that you're working with. Also, there is this concept of data type precedence. When you have an operator that combines two expressions of different data types, SQL Server has built-in rules for data type precedence that specify that the data type with the lower precedent is converted to the data type with a higher precedent. And this can sometimes cause unexpected performance behavior. You might be looking at it thinking, why didn't it change this particular, in this where clause here, why didn't it change it to this other value? And it didn't do that. Why is that? And I've experienced times where I had forgotten about the data type precedence sort of situation, and so it got it didn't work the way I had assumed. And again, one of the key problems with this whole approach is just making assumptions. Just kind of expecting it to work the way you think it's going to without double checking that and making sure. So I've got a little demo to show you here, and a couple things. Well, let's just start with a simple demo of actually what these, what a query might look like here. So one of the first things that you might see would be in a case where we have an implicit data type conversion. Here, national ID number, this is not its normal data type, and so SQL Server behind the scenes is going to have to go back and change this into a compatible data type in order to execute on that. The second statement actually declares everything and makes sure that it's done properly. And so if we get the actual plans on these, we'll see that there is some variation in what happens. Now these are tiny queries, so I encourage you not to look too heavily at things like the duration here. That's not really what I'm trying to show to you at this point. But, look at the execution plans down below. And just on a hover, you can see that the predicate has an implicit conversion right there in it. And we also see that there's a key lookup on this in this operation. If we go to the second operation here, now we have an index seek, and there is no implicit conversion happening. So,
well, there still is, but it's on the okay side where it's okay to do that.
Gracious, excuse me. Now, should I change that, Aaron?
No, I don't think so.
Okay.
So we'll have to go back, but just mention that it's okay to actually, now that I think about it, so if the underlying column is nvarchar, your demo should have nvarchar as the data type. Yeah, right
here?
There. Yep. So if you run that again,
let's do that.
I think that will get rid of.
Okay, let's see
So
here. Index scan,
yeah.
seek.
So if you hover over the index seek, that implicit convert should be gone. Yep,
Yes,
there you go.
you're a genius. All right, so let me explain that again. So if we take a look at two simple execution plans, and these are very simple, we're not going to be looking a lot at duration or CPU or that sort of thing, just to get the concept down. Here we've got a simple query that is definitely going to have an implicit data type conversion. In the second case, we're actually going to go ahead and basically tell SQL Server what the data type is for this value here. And so when it executes, it will not experience that data type conversion. So flipping over to the results, if we look at the first of the two, we can see there's a pretty expensive index scan happening. And if you look at the predicate there, you'll see that there's a convert implicit string there in the execution plan. This can cause all kinds of problems. The least of the problems is if it causes some additional CPU to figure out what it needs to do. But it can also cause a lot of additional I/O because SQL Server will frequently need to use either an index scan, if we're lucky, or maybe even a full table scan to resolve the query. If we take a look at the second one, in which we told SQL Server what the data type is, we can see that under the seek predicates, there is not a convert underscore implicit operation. And so very beneficial to us to get away from that. But again, even when we do look at if we go up top and we look at the estimated CPU and the number of reads and compare those between the two, we can see that there is some benefit both on the CPU hit and on the I/O hit for each of those. And this can also, this is a super simple query, but let's say we had a from with a join operation, and the two columns in the join were different data types. Then we could have an implicit conversion there. You can have it in all kinds of different places in the in the operation of your different queries and stored procedures and things like that. Now, a couple other examples, not of implicit conversion, but a couple tools, if you will, that I think you would really enjoy seeing. The first one is from our good friend Jonathan Cahias over at SQL Skills. He's written about this in several different ways and in several different blog posts, each time revealing new nuances to how this happens. This particular piece of code that I'm putting up here is on SQLblog.com. So if you take a look at SQLblog.com and look for Jonathan's name and the author list at the right, it won't take you but a few moments to find it. This is a kind of a long and crazy bit of code, but what I want you to zoom in on is down here at the bottom, in which he looks for convert implicit. So what he's doing is he's actually looking at the So it's one thing for us to be able to take a look at our code as we're writing it and say, okay, this particular piece of code I've written wasn't written well and I can do better. But what happens to a lot of us is we just simply inherit applications and things like that. So here what we can do, if we execute this against the plan cache, it will tell us all of the different queries, including the ones that I just ran. It'll tell us and find for us all of those different queries which have implicit conversion in them. And so we can see some of these different ones that I just ran and how they're showing up in the execution plan cache. So this is really, really useful little resource for tuning something that maybe somebody else has written. A lot of us as DBAs have to tune up what the dev team puts in production. So I really like having this in my toolkit. Now you notice it took a few moments to run, even just for a small number of hits here, like 6 hits. It can take a while to run because it's having to kind of shred all that XML and look through all of that information. So that's a little bit of extra work. So don't expect it to be really fast on a big high performance production system, but it can be extremely useful information. Another little utility I want to show you is from a person named Ian Sturck. Ian has written a really good book put out by Manning Press, and it's called DMVs in Action, SQL Server DMVs in Action. And one of his little utilities. I don't believe it's in that book, but you can find it online. I believe it's in the code library at SQLServerCentral.com. And he's got a little utility that he calls um, he calls the column mismatch utility. And so what this does is this takes a look at your different data. I'm sorry, your different tables inside of a given database. So here I'm in AdventureWorks 2008, and it will tell you all of the columns and so forth across different tables that have the same name but have different data types. So when I execute that one, you can see that I have a lot of column names called start date, but they're in different schemas. Some are in human resources, some are in production, some are in sales, and there's some differences. Some are just date, some are date time. If yeah, if we look down here, look at title. Title is all over the place. It's in
Oh, wow.
human resources, it's in the person, the production, and purchasing, but some of these are a lot different
Different,
from each
yeah.
other.
That's not good. That's where consistent naming scheme can really come into play.
Absolutely, and as I have found very often, a lot of it's not necessarily even restricted to homegrown applications. A lot of highly marketed third-party applications from big software vendors, you'll see that they have really pretty mediocre or even downright bad database designs. So it's always nice to have a second look at what you're buying, um, and to see whether they are actually kind of making a bed for you that is going to have a lot of problems.
Yeah, I wonder how many times the AdventureWorks customers entered an email address longer than 50 characters before they went out of business. How do they understand how they do that? How can you have 50
Yeah,
characters for your email address?
exactly. It's like that is just really really small these days.
Yeah, the tester, he had probably had an email address that fit in that size, but I'm sure there are some users that don't.
Yeah, exactly. There's millions probably now.
Yeah.
Yeah, so interesting little utilities for you to take advantage of. And I went ahead and took a moment and put those here on this slide for you. So again, as I mentioned, you can go to SQL Server Central and they have a script library there that you can check out. Or you can just query on Ian Stirk and the column mismatch utility, and you'll get that hit there. And then Jonathan Cahias at two different locations. So in one case on SQLblog.com, John has this really good script to analyze your plan cache to see if you already have anything in the cache with implicit conversions. And again, that's the kind of thing I've used many times with customers who are complaining about slow performance. Also, you can look at a really neat blog post that he put up at SQL Skills, and he's also done some on on SQLperformance.com about case studies in which he looks at specific scenarios for performance of implicit conversions. And so one that I like to cite is the one he did at SQL Skills that talks about those kind of various kinds of conversions, implicit conversions that cause index scans. And so he's got some really kind of exhaustive testing he's done there with lots of different scenarios and situations. It's a really, really good place to build up your body of knowledge about this behavior. All right, let's jump on to the comma-delimited parameters train.
Okay, sounds good. So this is about splitting strings. This is a long-time favorite topic of mine. It's been beaten to death, but I still see people spending hours of backbreaking labor trying to squeeze an extra second or two out of an inherently inefficient T-SQL approach to parsing a comma-separated parameter. So they, people will use a single parameter to pass in a list of values that are separated by commas. So even when using CLR, which is pretty good at string handling, this approach is antiquated, and I implore people to start looking at better ways of doing this. So I'm going to grab the screen and take a look at a quick example. Okay, so this example we're going to look at is just a store procedure that where we pass in a comma-separated list of order IDs. So these are integers. Say that a user selected these order IDs from a multi-select dropdown on a form or a series of checkboxes. maybe they're auditing orders, something like that. But they need to return a set of orders that don't really make sense, to do individually. So they want to grab
Mm-hmm.
a list of some kind, and they want to do it as efficiently as possible. So
Sure.
the typical way that people have done this is a split function. So implementations may vary. I'm sure there are 100 or more ways to write a split function that will split a list of integers. This is the one that I typically use. It uses the numbers table that we talked about in my previous example to basically find all of the occurrences of our delimiter. In this case, it's a comma, and make a set out of the values in between. So I don't want to elaborate too much on the split function itself, because I'm not trying to teach people how to write a split function. I want to teach people how to not use a split function anymore. So that's our split function. And this will be downloadable, so you'll be able to look at that closer if you want. Now, this store procedure is the one that makes use of the split function. So basically, we pass in the CSV. We can use varchar here because we're passing integers, so we don't have to worry about Unicode. Typically, when you're passing in comma-separated strings, you have to use mvarchar because you're typically you have to worry about Unicode most of the time when you're dealing with strings. But when you're dealing with ints, you don't have to, so you can use half the size, basically, of that string that's coming in. So the store procedure just basically does a select from sales order header enlarged. This is another thing that Jonathan Cahias has graced us with, is this a script that he has to enlarge the sales order header and sales order detail tables so that you can run more meaningful demos that actually do enough I/O or enough CPU to demonstrate the differences in performance that you can't really see from the base AdventureWorks tables. So that's basically what it does. And then if we go to the next example, so another way that people do this is they'll just append that CSV parameter into dynamic SQL. So you can't just say in and then pass in the parameter because it's the wrong data type, right? You're going to be looking for sales order IDs that are equal to this big long string. So, but if you do it with dynamic SQL, you can place that constant in there, and when it gets evaluated, it'll actually be the comma-separated set of values, which by rights should be pretty efficient. And then another way we can do it is to use a table value parameter. This is something that's new in SQL Server 2008. It's extremely powerful, and I highly recommend you look into it. So basically what we do first is we create a table type. So I'm just using a generic name here called numbers. Conflicts with my numbers table, but that's in a different database, so we're not going to worry about that. I probably could have used a better name, but I wanted to make this as generic as possible. So basically it's a table type that's going to hold a set of unique numbers. And then the store procedure is only slightly different from the split function. So we have our create procedure. We pass in a parameter as the types. So that parameter name, or the data type, is actually the table type that you see right above. And we have to use read-only. This is a limitation of TVPs for now that will hopefully be lifted in some future version. And then down below, just like with the split function, we just join against it. Okay, so how efficient is this? Well, let's test it out. You'll notice that I used select into as opposed to just select. And the reason I did this is so that I could run this procedure many, many times without worrying about consuming the result set in the client, right? So if I just dump stuff into a temp table, I'm performing all of the logical operations that I would do if I were running these queries directly, and actually some extra I/O by dumping it into a table. But I don't have to worry about consuming 1,000 result sets if I run the store procedure 1,000 times, right? Nothing's going to get returned to the client.
Mm-hmm.
So the split function, we have a set of 30. I actually pick these values by doing a select from the sales order header and large table, select top 30, order by new ID. So these are absolutely random values, but I picked them specifically so that I could reuse the same set. So I'm not getting any variations here because my second random set was more selective or less selective or what have you. Which shouldn't matter because it's unique in that table, but I just want to use the same values just to be consistent. So basically we declare a datetime2 variable and an integer. These are used for measuring the time and keeping a counter. declare a CSV, this comma-separated list of hard-coded values, and then we loop through 1,000 times and execute the store procedure. And then at the end, we see how long it takes. And we do the same thing for dynamic SQL, and then for, and I called the output unsafe dynamic SQL because one of the problems with this is that it exposes you to SQL injection. And then finally, for the TVP, we have to populate the value slightly differently. So we declare a parameter of that type, and then we insert using the multi-values clause, and then we execute that store procedure 1,000 times. And let's see how these perform. Back up to split. Let's run these. We'll see how long they take. All right, so the split function took about 2 seconds. The dynamic SQL took 2.5 seconds, and the TVP took under a second. Now I'm going to run these again, just so that I'm not hiding a rabbit in a hat or something, or dealing with one of these sets is cached and one of them is not, that kind of thing. Pretty consistent performance. About 2 seconds for the split function, 2.5 seconds for the dynamic SQL, and under a second for the TVP. And then if we look at the plans here. So these are the same things, except now we're just looking at one instance of each invocation. We're not worrying about running them 1,000 times and comparing the time. We just want to see what the plans look like.
Right, right.
And we see some fun stuff here. So we have really high number of reads for the split function. Really high number of really high estimated CPU. Duration for the split function and dynamic SQL are about the same, but again, this is one run of a small set of 30. We have to take into account that as that set of order IDs that you're passing in gets larger, that this will go up and be more problematic. We also didn't do any other table access. We only accessed that clustered index. And if you're doing other joins and everything else, you can see that this will have a cascading effect. Another interesting thing to look at is if we go into the split function and look at the estimated rows versus actual rows, we see that we get a factor of about 1,000 for every invocation of the table value function. So we have 30 rows. We invoke the table value function 30 times, multiply that by 1,000, we get 30,000, and then some additional for the other stuff that's going on. Our estimated rows are much higher, and we don't see that symptom on any of the others. Right, so for this one, if we dig down, we've got a select here, and we're a little bit off. When we look at the TVP, we're identical. So estimated rows and actual rows, SQL Server knows exactly what it's after, as opposed to the other two cases where it can be way off because of the table value function, or not being able to sniff what that dynamic SQL parameter would be. Okay, so when I wrote this, I first wrote it using exists. So the TVP, if we go back to the TVP store procedure, it has a join, right? So if we go up a little bit, I use inner join IDs as I. What I want to do is I want to revisit this a little bit and just take a little tangent, if that's okay, Kevin.
Absolutely.
I want to talk about just generalizing about observed behavior. So when I first wrote this, like I said, I wrote it using exists. Since I didn't actually need to return any data from the TVP, I thought that since prevailing wisdom is that exists is as or more efficient than equivalent join, I would get the best efficiency out of using that approach. Would you say that's a pretty common conception, Kevin, that exists is as good or better than a join?
Yeah, definitely.
So we're going to peel the onion a bit here and compare these and really see if that's always the case. And again, I just want to stress that you should not rely on something you observe once or in a few narrow scenarios to be universally applicable. It's not always the case in SQL Server. So I created a new set of store procedures for this, just to completely isolate from the other things that I've done. One takes the TVP and uses the join. This is exactly the same as the demo we just did. And the other one is what I originally wrote, which is an exists. So because I don't need to perform a join here, I can just say where exists, because all I'm looking at are the 3 columns from the sales overhead or large table. I'm not actually returning any output from the table value parameter. So I can just use exist, and hopefully, because what I usually think is that I'm going to potentially benefit from some short-circuiting here, or at worst, it'll be the same behavior as the join, depending on whether the join in here is unique or not, and selectivity and other things like that. But I would expect the behavior to be quite similar. So I've created these procedures already, and I'm going to run the same test as I did before. Declare a variable that tracks the time, and then the loop counter, insert into the TVP, and then measure the duration. Do one for exists and one for join. Back up here.
All right, looks good.
All right. So when we run these, the exists takes 1.5 seconds. The join takes under a second.
Wow.
Isn't that interesting?
Mm-hmm.
I bet you didn't see that coming, Kevin.
I did not.
Yeah. So the join is outperforming the exists by 2 to 1, roughly. Now, a little bit lower than that, but pretty close. So let's run it again to make sure there's no caching or other dirty tricks going on. 1.5 seconds and under a second. So we take a look at the plans in Plan Explorer. Got them here already loaded, so we don't have to run them again. Everything looks pretty similar. So if we take a look at these, we've got slightly higher duration, but again, 3 milliseconds versus 2 milliseconds for a single call. That shouldn't really be that much of a difference when you look at it en masse. A little bit higher CPU, a little bit higher reads. I wonder why there would be higher reads for the exists versus the join. They should be the same, I think. So if we look at the
sometimes even less, because the exist will stop once it finds the first record.
Right. Sometimes we see some short circuiting. So if we look at the diagrams for the select, all right. So we've got a table insert, a nested loop, a cluster index scan, and a cluster index seek. Seems pretty typical. If we look at the join method, table insert, a nested loop, a clustered index, these are the same. These are identical. I can't figure out what's different, except for the reads number here. If we look at the table I/O, let's take a look at the table I/O tab. So we've got 100 logical reads on the base table, 2 logical reads on our table on our TVP, and then if we look at the exists version, same thing, 100 logical reads and 2 on the TVP. I'm going to save you some suspense because I could look around and poke around here for an hour trying to find something. If we move to the expressions tab, if we look at the join, we've got 2 expressions here, 2 compute scalars. And if we look at the exists, we have an extra expression. So here we have set identity. This is interesting. So this extra expression is actually the cause of our pain, but we might never know that. If we had looked at this in Management Studio, take a look at this in Management Studio. Take a look at these plans. So this is the same query that I just ran. Take a look at this. We've got 48%, 48%. So this is the first number that people often look at, right?
Yep.
And so what people are going to do when they look at these two things, they're the same. These are the exact same performance characteristics. And if you look at all of the properties, all of the tooltips, all of these things are going to tell you the exact same things, right? So none of these factors change. So looking at Management Studio, I have no idea why these are different.
Right.
So if we go back to Plan Explorer, so I'm going to explain why this happens. Now, if you remember, I used select into in these procedures so I could run them over and over again without having to consume the result sets in the client. Well, select into has some interesting properties depending on the source query. Most importantly, and what's affecting us here, we maintain or retain the identity property if the from clause is restricted to one table. So that's true in the exists case, since the other reference is filtered, but not in the join case, which explicitly lists 2 tables. So the extra I/O and CPU involved is basically SQL Server setting identity insert on in order to populate the explicit values in that new temp table we created. Whereas in the join case, we're just selecting into, and so we're saving, obviously we're saving some duration there. If you look at the case where we ran it 1,000 times, we're saving half the time, roughly, by not having to worry about that identity column. So some pretty interesting stuff, and not to toot our horn too much, but this would have been really tough to track down in Management Studio. So if you're not using Plan Explorer, why not? Um,
Yeah, wow, good catch.
so, so the morals here to my talking about splitting strings. One is if you're currently using some kind of split function or dynamic SQL to deal with comma-separated parameters, think about using TVPs instead. They might not work better, but they could. You just need to change your application to send a data table or some similar struct as a parameter instead of sending in a string. And the other is to be very careful about making generalizations about observed behavior or even trusting too much in what an estimated or even an actual plan in Management Studio might tell you. In this case, I would have no idea how to explain the difference in duration, since it defies the typical wisdom about how exists work and how it can never be worse than a join. And there's nothing in the plan really that gives you any idea why the performance is different. So this is stuff that we pull out of the XML that would be very hard to track down yourself.
Wow. Yeah, that I didn't even know that it would make it so easy to find that. That is neat. All right. Well, let me jump back in if you don't mind. We're almost out of time, but we have just enough time to cover one more interesting little detail that gets a lot of us and hurts our performance. There's a lot of kind of misperceptions and myths about temp variables in particular, and also to some degree about temporary tables and which temporary structure is better for which situation. I was going to spend a little time showing some demos about some of these things, but frankly, there's a million different use cases, and so what I thought would be better would be to just provide you some overall education on how the two different types of temporary objects behave and what they're actually quite good at and what they're not. And one of the most predominant myths about temporary variables that I run into over and over again, and Aaron, I'm sure you can back me up on this, but I constantly hear people say temporary variables are stored in RAM.
Yes, I've heard that many times.
Yeah, it's stored in SQL Server memory. And I know I actually perpetuated that idea back in the SQL Server 2005 days. I used to think that was the case too. But it turns out that temporary tables, any table defined with a pound sign or double pound sign if you want to have a global temporary table, those are instantiated inside of tempdb, but temporary variables are also created inside of tempdb. So they both cause disk I/O, they cause activity on the subsystem, and so you don't get this kind of mystical and mythical benefit of doing all of your work entirely in RAM. Now, another big difference between the two, and perhaps one of the most significant, is that SQL Server, the dev team uses the term scaffolding. So tables inside a SQL Server have some default scaffolding built around the table itself. So even if you never, and I'm talking about permanent tables here, so even if you never create an index on a table, but you do use kind of standard search arguments against that table. So you have select statements with join clauses and with where clauses that filter on specific columns. SQL Server will actually begin to create some statistics on those. And that's part of the auto create and auto update statistics features of SQL Server. Well, the good news for us is if we use temporary tables, SQL Server has that same scaffolding in place for those temp tables. So yes, SQL Server will begin to collect statistics, even if you don't tell it to do that. On the other hand, temporary tables also fully support the whole schmear, the whole shooting match of statistics. It's all built in there because they are a regular old table, except with the property of their temporariness, if I can use that term. Temp variables, on the other hand, don't have statistics. Whenever SQL Server sees a temp variable, it always assumes, and you cannot change the assumption, that it has just one row. So that's kind of its shortcoming for statistics. A little bit more explanation in the next line about indexes and keys. So again, temporary tables, they have all the normal requirements and restrictions that a SQL Server table has for the number and type of indexes and the number of type of keys that you might have. Temporary variables, on the other hand, are only allowed to have one unique key or primary key that's defined when it is created. And you can have you can have no more than that and no alternatives to that. So
There's Kevin. There's a change coming to SQL Server 2014 that you will probably never see in a Microsoft marketing demo or in one of their slide decks. That restriction is actually being lifted,
oh,
where
interesting.
you will be able to create additional non-clustered indexes on a table variable.
That's
Only at
interesting.
create time, though. You can't alter the table, but
Right.
you can create them as part of the inline. So they've basically expanded the DDL for declaring
Right.
a table
Right.
variable.
Well, and that point actually kind of dovetails very nicely with the next point on the chart here, truncate. So, truncate is really, really nice because if you need to delete, erase all the records in a table, truncate doesn't do the same level of transaction log logging. Now, it is still logged, but it's minimally logged. So it's much faster and easier to truncate a table than it is to delete everything out of the table. And temporary tables support that, but temporary variables don't support truncate. So kind of like what you're saying there, Aaron, I think that they're probably doing some upgrades on what the temp table can support in terms of the various DDL and DML statements, that sort of thing.
Yeah, and that's the only thing I've tested so far. I don't know if any of the other variables you have here are actually changing in 2014. So definitely something I'll put on my queue.
Okay, all right. Now, on the good side for temp variables is this point about recompiles. One of the things that happens a lot if you have a stored procedure, for example, and we talked about this in our last webcast, or perhaps two webcasts ago, in which if you interleave DDL and DML statements, so like a create table statement, even if that's a temporary table, with an insert into that. Every time you interleave, SQL Server has to recompile because it's not sure if everything is the same after the new DDL statement runs, the new create or alter or drop statement runs. So it has to recompile. SQL Server doesn't have to do that with the temporary variables, so it does provide a bit of a benefit there. But there's lots of and these are just a few. There's actually longer and more kind of obscure reasons why you might decide not to use temp variables or temp tables in a given situation. One of which is if you have a lot of parallelism that your table your operation could benefit from. Maybe you just wanted to do a large select operation of 1,000,000 records from this temporary object, and you knew that they were broken out very nicely, evenly distributed by range. So you've got 4 CPUs available to SQL Server, and each one could grab 250,000 records. Well, a temporary table can support that kind of parallelism operation, but temp variables can't. And again, a couple others on the pro side for temporary variables is that it has a little bit lower metadata overhead in the way it locks, and also it just has a little bit lower overhead in terms of user transaction locks. So one example of the user transaction lock benefit of a table variable is that SQL Server will keep keep the transaction log open as long as a user transaction against a table is still in flight. And that could be really bad if you explicitly opened a transaction but you didn't explicitly commit it or roll it back. It could be minutes or hours before that eventually gets wrapped up. Whereas SQL Server doesn't do that with table variables. So if you start a transaction against a table variable, SQL Server can still truncate the transaction log if it wants to, while that is still operating, whereas it will not do that with transactions against a temporary variable. So if you have long-running transactions that are going against temp tables, that would be a situation where you might consider, hey, maybe a temp variable will work better for this one particular situation. But again, it's the kind of thing where don't make assumptions. The more you know about each of these different structures, the more you can effectively utilize them for their strengths and also avoid them because you know what their weaknesses are and what they're not good at. All right, so hey, that's it. We've gone just a smidge over time. A couple points to summarize on. Aaron, why don't you hit the summary this time and as we wrap
Sure.
up? Okay.
Okay, so one of the things we talked about was the comma-delimited parameters, so splitting strings, may actually work out better for you than by using TVPs instead of doing it the old-fashioned way that you're doing it now. Another one is that implicit conversions. Kevin, you spent a lot of time showing how these can cause extra CPU and or I/O and additional scans that aren't always necessary and aren't always going to be obvious that they're happening.
Mm-hmm.
I talked about some ad hoc, deriving ad hoc sets, so ranges of dates or ranges of numbers, and the usual go-to today is recursive CTEs, and you really should test some alternative methods of doing that, such as having a built-in numbers table or built-in calendar table that's always available for use in your systems. Mm-hmm. And then finally, you just talked about temporary tables and table variables, and how they each have their uses and what kind of things that you will see when you use each of them. So.
Mm-hmm. Yeah, informative stuff, and thanks for sharing, particularly on that little digression there. That was definitely some new stuff that I had never seen before.
Sure, no problem.
Okay, so
I was actually kind of surprised by it too.
Yeah, that's kind of neat too, folks. As we work on these different challenges, and as you come back to us with questions and so forth, SQL Server is a big world. So Aaron and I will be the first to tell you, even though we've been working with it since its very inception, we are still learning stuff on a regular basis.
And some of the stuff is everything old is new again. So I had a conversation with Paul White this weekend about this very symptom that I was seeing, and he showed me that I filed a Connect item about it like 4 years ago. So yeah. It's not something that I hadn't seen before, but it's something that, when you're working with technology long enough, you forget half the stuff and you forget half the problems that you've seen in the past that you haven't encountered in a long time. Mm-hmm. And so, I was surprised by this thing, and then I went and read my Connect item, and sure enough, I say it right there that this identity thing can cause problems on select into depending on the source. So it's kind of interesting. So.
Wow, that's cool. Also, we didn't talk about it much this time, but answers.sqlperformance.com is a really neat website. If you're using our free Plan Explorer tool, which we've used in all of our demos today, you can upload your various challenging execution plans to the answers.sqlperformance.com website, and we will tackle those. So Aaron, Paul White, who we just mentioned a moment ago, probably the preeminent execution plan analyst out there, they'll take a look at it and they'll tell you how or why it is misbehaving and how to improve that. We also have a link here for you to get that tool if you haven't gotten it for free. It's a wonderful tool, and it's used by most of the bloggers and SQL Server writers and MVPs out there. And then also, I would love to help you out with any of our other tools. So if you want to look at our monitoring tools, our event management tools and alerting tools, or perhaps the professional edition of Plan Explorer, take a look at SQLcentury.net/download, and I'll be notified of that. And if you are interested, you can always drop me a note as well, and I'll make sure you get a personal face-to-face demo on any of the products. And if not, we won't bother you. We're just making that available for you. Okay, well, with that, thanks so much for spending an hour with us. We hope that it's been worth your time, and we look forward to hearing your feedback. Please ping us on Facebook or send us a note on Twitter. We'd love to get your interaction and your input.
All right, see everybody soon.